Most people think space is silent, empty, peaceful. But beyond Earth's atmosphere, the universe is constantly tearing itself apart. Stars explode with enough energy to outshine entire galaxies. Invisible storms race across space at millions of kilometers per hour. Dead stars unleash bursts so powerful they can erase the atmosphere from a planet. And somewhere out there may already be a disaster heading toward us that we would never see coming. These aren't science fiction. They're real cosmic catastrophes, and each one is more terrifying than the last. Solar storm. The most dangerous space disaster doesn't begin millions of light years away. It begins just 8 light minutes from Earth. Our sun looks calm, but beneath its surface, billions of tons of superheated plasma twist around powerful magnetic fields. Eventually, something has to give. The magnetic field snaps violently, and the sun spits out a solar flare, a flash of energy powerful enough to outshine anything humans have ever built. Right behind it comes the real threat: a coronal mass ejection, a wall of charged particles hurled into space at 2 million kilometers an hour, a loaded gun pointed in a random direction. If that cloud misses Earth, nothing happens. But if it hits, the effects can be global. Satellites fail, GPS disappears, radio communication goes silent, power grids overload. In 1859, a massive solar storm known as the Carrington Event sent electric currents through telegraph wires, shocking operators and setting equipment on fire. Back then, the world barely relied on electricity. Today, the same event could disrupt modern civilization for weeks or even months. But as powerful as our sun is, it can't erase an entire planet. The next disaster already has. Asteroid Impact. 66 million years ago, Earth wasn't ruled by humans. It belonged to the dinosaurs. Then, without warning, a mountain-sized asteroid slammed into what is now Mexico. The impact released more energy than billions of nuclear bombs. The ground shook across the planet. Mega tsunamis raced across oceans. Wildfires spread over entire continents. Dust and ash blocked sunlight for months, possibly years. Plants died. Food chains collapsed. Nearly 75% of all species vanished, including every non-avian dinosaur. And here's the unsettling part. Right now, agencies are tracking thousands of these rocks. Most will pass by and never come back. But somewhere in that list, maybe one we haven't even found yet, is the one that matters. And we might not get 66 million years of warning next time. Still, even asteroid impacts are tiny compared to what happens when a star dies. Supernova. Stars spend millions of years fighting gravity. Fusion pushes outward, gravity pulls inward. Eventually, the fuel runs out. Gravity wins. In less than a second, the star's core collapses. Then everything reverses. A shockwave tears through the star, blasting its outer layers into space in one of the most violent explosions in the universe. A supernova can briefly outshine every star in its galaxy combined. The explosion forges many of the heavy elements around us: the iron in your blood, the calcium in your bones, even the oxygen you breathe. All were created inside stars that exploded long before our sun was born. But a nearby supernova isn't just beautiful. If one occurred close enough to Earth, the intense radiation could damage our atmosphere and expose life to dangerous cosmic rays. No star close enough to hurt us is dying anytime soon, probably. But the universe has something even more extreme, an explosion so powerful it makes a supernova look ordinary. Gamma ray burst. Imagine concentrating more energy than our sun will produce during its entire lifetime into just a few seconds. That's a gamma ray burst, the most energetic explosion ever observed. Most happen when enormous stars collapse into black holes, or when two neutron stars collide. As the collapse happens, narrow beams of gamma radiation shoot across the universe at nearly the speed of light. If one of those beams happens to point toward Earth from close enough, the consequences could be catastrophic. The atmosphere could lose much of its protective ozone layer. Dangerous ultraviolet radiation would flood the surface. Entire ecosystems could collapse. The odds of one aiming at us? Astronomically small. But somewhere out there, one already has our address, we just don't know it yet. And the next disaster doesn't rely on explosive energy at all. It comes from something far stranger: A dead star, with a magnetic field so powerful it can reshape reality around it. Magnetar. When a massive star dies, it doesn't always become a black hole. Sometimes, it leaves behind something even stranger. A magnetar. Imagine compressing more mass than our Sun into a sphere barely 20 kilometers wide. Now give that object the strongest magnetic field ever discovered. A magnetar's magnetic field is so powerful, it can distort the very atoms around it. If one somehow came halfway between Earth and the Moon, it wouldn't need to touch our planet. Its magnetic field alone would destroy electronics across the globe. Every hard drive, every satellite, every power system, gone. But magnetars don't stay quiet. Every so often, stress builds inside their ultra-dense crust. When that crust suddenly cracks, the star releases a giant flare in just a fraction of a second. It can unleash more energy than our Sun produces in hundreds of thousands of years. In 2004, one such flare erupted from a magnetar nearly 50,000 light-years away, even from that incredible distance. It disturbed Earth's upper atmosphere. That's the power of a dead star. But at least magnetars announce themselves with light. The next disaster doesn't, because you can't see it coming. Rogue black hole. Black holes are terrifying enough, but most stay where they were born, orbiting quietly around the centers of galaxies. Not all of them. Some are violently thrown into deep space after the explosion that created them. These are called rogue black holes. They drift through the galaxy completely alone. No glowing gas, no companion star, no light, nothing. Imagine an invisible object, several times heavier than our Sun, wandering silently through interstellar space. If one passed through our solar system, you wouldn't see it. You wouldn't hear it. The first sign could be the orbits of distant planets beginning to change. Comets could be pulled from the edge of the solar system. Asteroids could be redirected toward the inner planets. Gravity itself would become the warning. Space is big, really big. The odds are tiny. But tiny isn't zero. And this is the one disaster that could already be en route right now, and we'd have zero way of knowing. But gravity can create something even more spectacular. Instead of swallowing planets, it can destroy entire stars. Tidal disruption event. Every star has a safe distance. Cross that invisible line around a supermassive black hole, and there is no escape. The side of the star closest to the black hole feels far stronger gravity than the far side. The difference becomes so extreme. The star begins to stretch, longer, thinner, until gravity literally tears it apart. Astronomers call this a tidal disruption event. But another name describes it even better: spaghettification. Streams of stellar material wrap around the black hole like water circling a drain. Some of that gas falls inward, heating to millions of degrees. The result is a brilliant flash that can be seen across the universe. For a brief moment, one dying star becomes brighter than an entire galaxy. It's one of the most violent deaths nature can produce. But even black holes aren't responsible for the next disaster, because sometimes the most powerful explosions happen when nothing explodes at all. Kilonova. Take two neutron stars, each one heavier than our Sunday, each one only about 20 kilometers across. Now let them orbit each other for millions of years. Every orbit releases tiny ripples through space-time itself. Slowly, they spiral closer, faster, and faster, until they collide. The explosion is called a kilonova. For just a few seconds, it releases an unimaginable amount of energy, but that's not what makes it remarkable. Inside that collision, the universe creates some of its rarest elements. Gold, platinum, uranium. The precious metals on Earth were likely forged in disasters exactly like this billions of years ago. In 2017, we finally caught one in the act. For the first time ever, scientists didn't just see the flash, they felt the space-time ripple that came with it. Light and gravity, arriving together from a collision 130 million years in the past. It was the moment astronomy learned to listen and watch at the same time. Yet even this isn't the most terrifying possibility, because every disaster we've talked about still follows the laws of physics. The final one could rewrite them completely. Vacuum decay. Everything around you depends on the laws of physics remaining exactly as they are. Gravity, light, chemistry, Atoms, life itself. But what if the universe isn't as stable as it seems? Physicists believe empty space isn't truly empty. It's filled with invisible quantum fields that determine how reality behaves. Right now, those fields appear stable, but some calculations suggest they may not be in their lowest possible state. Imagine balancing a ball inside a shallow valley. It looks perfectly safe, until one tiny push sends it rolling into a much deeper one. If the universe is in that kind of unstable state, a random quantum event could trigger a transition. A tiny bubble would appear somewhere in space. Inside that bubble, the laws of physics would be completely different. Atoms might no longer exist. Chemistry could stop working. Matter itself could become impossible. The terrifying part is how it spreads. The bubble expands at the speed of light. There would be no warning, no signal, no chance to escape. The first indication that it happened would be the moment it reached you. We don't know if vacuum decay is possible. It may never happen, but the mathematics hasn't ruled it out, which means somewhere in the endless darkness of space, the universe may still be hiding disasters we haven't even imagined. Because the more we learn about the cosmos, the more it reminds us of one simple truth. Space isn't empty. It's alive with unimaginable power, and humanity has explored less than a fraction of it. Who knows what the next natural space disaster waiting to be discovered will be?